Example 1. Figure 4.8 shows two resistors 20 ohms and 5 ohms in series. If the PD across both resistors is 20 volts, calculate the current flowing in the combined resistor. Solution. Combined resistance R in series, R is equal to 20 plus 5, which equals to 25 ohms. From Ohm's law, V over R, it follows that I is equal to V over R, which is equal to 20 over 25, which will give us 0.8 ampere. Parallel resistor. In figure 4.9, the combined or total resistance R of resistance R1, R2, R3 is given by 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. One, the total effective or total resistance R is less than the least individual resistance. 2, the total current is the sum of currents through the resistor. 3, potential difference across each resistor is the same. Example 2. Calculate the total resistance of the circuit shown in figure 410. The diagram of 410. Resistance in parallel. 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Substituting the value, you have that 1 over R is equal to 1 over 3 plus 1 over 4 plus 1 over 2, which is equal to 13 over 12. R is equal to 12 over 13. Example 3. There are 5 ohm resistor connected in parallel having a potential difference of 60 volts and are applied across a combination. Calculate the current in each resistor. Solution. The potential difference across each resistor is the same. From Ohm's law, V is equal to IR. Therefore, I is equal to V over R, which is equal to 60 over 5 ampere, which will give us 12 amperes. EMF and internal resistance of cells. A cell or a source of energy drives electrons through a circuit. Electromotive force. The electromotive force EMF E of a cell is the total energy per coulomb obtained from a cell, or the total energy required to send a unit positive charge around a complete electrical circuit. The unit is expressed in volts, capital V. Internal resistance. The internal resistance R is the resistance of the battery or generator while working. Formula. The EMF E is the potential difference PD across both external and internal resistance. If R, capital R, is the total external resistance and small r is the internal resistance, then electromotive force E is equal to IR plus IR, where IR is the drop and IR is equal to V. I is equal to E all over R, big R plus small r. Since E in bracket E minus capital V is equal to potential difference across internal resistance R, small r, then the current is given by I equals to capital E minus capital E all over capital R. Note, potential difference V is equal to capital E minus capital I small times small r. Example 1. A battery of EMF 20 volts and internal resistance 5 ohms is connected to a resistor of 35 ohms. Draw a diagram of the circuit and calculate the terminal potential difference PD. Solution. Looking at figure 4.2 example, capital E is equal to capital V plus capital R times small r. But we know that I is equal to capital V all over capital R. Bringing out V from the bracket, we have that V equals to I1 plus small r over big R, where I is equal to V, capital V over R. Therefore, you now substitute the value. You have 20, which is the electromagnetic force, equals to V in bracket 1 plus 5 over 35, which will give us V equals to 1 plus 0.143. Then, collecting like terms together, we have that 1.43 V is equals to 20. Making V the subject of the formula, we now have 20 over 1.143, which will give us 17.5 volts. Therefore, total terminal PD is V, capital V is equals to 17.5 volts. Example 2. A cell of unknown EMF has an internal resistance of 3.0 ohms, an external resistance 10 ohms is connected to the cell. If the potential difference across the 10 ohms resistor is 1.5 volts, find the EMF of the cell. Solution. Capital I is equals to capital E all over big R plus small r, which is equals to capital V over capital R. Electromotive force capital E all over 10 plus 3 is equals to 1.5 all over 10. Therefore, capital E is equals to 1.5 times 13 all over 10, which gives us 1.95 volts. Alternatively, electromotive force E, capital E, is equals to capital V plus capital I times small r, which is equals to, substituting the values, we have 1.5 for the capital V plus I is 0.15 times 3, which is equals to 1.5 plus 0.45, which will give us 1.95 volts. R1, R2, R3 resistance assist one another. Then total EMF is equals to E1 plus E2 plus E3.